He's in YouTube. So we're about 7 or 8 weeks off from the initial SHSAT date. So hopefully everybody is knee deep into this preparation stuff. Remember not to go too overboard, guys, because you need to strike a balance. You can overstudy and not get to be absorbing something at some point. So today I'm going to kind of have a different kind of a problem. You may have seen something like it or not, but it's kind of, in a lot of examples I see, it's often not covered. And with all the kids I have ever showed it to, anything along these lines, I don't think there's ever been a kid who can solve it straight up right away initially. So let's jump into the problem. This is a lightning round. So here's our example. Actually, I'm going to leave the answers off for 1 second. So Tyrone has $3. He spent the whole amount, minus 12 cents he owed his brother, on marbles. If each marble had been a penny cheaper, he would have been able to get 4 more marbles than he did. How many marbles did he actually buy? All right, so let's go through this one more time, taking it a sentence at a time. So Tyrone has a certain amount of money. It's $3. Okay, no big deal per se right there. Okay, he spends the entire amount on marbles, minus 12 cents. All right, so let's start writing down what we know. Let me make sure the stream is live. Okay, yes, it seems to be. So let me just make sure. 1 more second. Let me move this down so I can see that too at the same time. Okay, there we go. So he has $3. He owes his brother 12 cents. You know what? My phone shut off. Give me 1 more second here, guys. There's nothing like having a nasty problem with the phone not working. All right, there we go. I think we got everything up here now. Let me do one more thing. Let me bring this to the top so it shows. Okay. So if we do that subtraction, we get that he has $2.88 then to spend. Okay. So he spends the whole amount of marbles. If each marble had been a penny cheaper, we don't know the price of the marble, but if it had been a penny cheaper, he would have been able to get 4 more marbles than he did. Okay? So when you get a problem like this, first of all, we already subtracted the cents. So we kind of, it's good, and this is kind of a running thing that we do often all the time anyway, is once you've done one part of a word problem, you've basically rewritten the problem to a different problem. Okay? So we got rid of the 12 cents, so we're really looking at $2.88, and we've kind of thrown away the whole $3 thing. All right? The second thing is, once you have a problem with dollars and cents, you normally want to make a choice whether you want to stay with dollars and cents or just convert it to all cents. So in other words, is this $2.88 or just 288? Okay? For my preference, I often like to go to just the whole penny count. But again, it depends on the problem. So on something like this, you're better off just going to the penny side of it. It's not going to be deadly if you don't, but I just like throwing that away. And that way, I kind of don't care if I'm dealing in dollars and cents, in dollars and pennies, in euros. It doesn't matter. So what we basically have is the price of something times the count of them. So P is the price, and N equals the number of the things. So that means we have P times N equals 288. All right? So that's our problem. So he gets a marble for a certain price. He gets X number of marbles, in this case it's N, and it becomes 288 cents. Or 288 something, just some units. All right? This is similar when you have a grid and it shows you something in here. you don't often care what kind of units it is. Maybe till the end, and then you scale it up, especially if there's a key or a legend, so you can do the same thing here. So if we go back to the problem, it's telling us if each marble was a penny less, that's this. If it was a penny less, he would have been able to get 4 more marbles. So this is n plus 4. And the price still would have been the same. That's what it's talking about. He spent the whole amount on his marbles. Nothing talks about a remainder. This is what you have to do and infer and interpret when you're reading the word problems. All right? So now we have 2 things, this, and this is going to be multiplied, where it's equal to 288. So when you see a problem like this, and it doesn't have to be worded the same way this problem was worded, it could be worded different. When you see a kind of problem like this, where 2 things are multiplied and they end up being the same number, think factoring. Okay? And by the way, there's about 5 solutions to this problem. I'm not sure really at this point, even though this is a live stream, actually how many I'm going to show to you guys. Because each one is kind of lengthy, and this was supposed to be a lightning round. All right? So what we need to do basically is factor the 288. All right? And that means you need to know things like your division by rules and so on. Because the more you look at the problem, right, on something like the SHSAT, you want to answer the problem in a minute and a half. And if you were lucky to answer some other problems in 15 seconds or 30 seconds on something that's harder or lengthier or just more annoying, like this problem, you may want to 2, 3, 4, 5 minutes on a problem like this. Or you may choose, if it's so lengthy, just to skip this kind of problem. I prefer you didn't, because once you know how to do it, it's semi-obvious. But let's go through it so you can kind of see what's going on here. So let me try to keep these on the screen, because I want to keep these on the screen with these basically 2 formulas here. So I'm going to end up writing factor pairs out. So I have 1, I have 288. Okay? 288 is even, so there's an even factor. It's 144. So is this divisible by 3? If you know your division by rules, if the sum of the digits is divisible by 3, the whole number is. So we get 16, 17, 18, so we get that. So we actually have to do the division by 3, and we're going to get 96 when we do that. My phone's dying again. You know what? I think the battery is screwed up. So, okay, 4. Division by 4 rules. Does anybody know what that is? Okay, most of you don't. Okay, when you have division by 4, it means the last 2 digits are divisible by 4. In this case, we have 88, and that's true. So when we would do that, we end up getting 72 when we do that division. If I actually do all these divisions, it's going to take too long for you guys. Okay, 5, it has to end in a 0 or a 5, so that's not the case. 6, so when something's divisible by 6, it's divisible by 2 and 3. So we know they both have, we already had that, so we're going to do 6 as well. So when you get 6, you get 48. Okay? You're going to try 7. The rules like 7 and 8 and 9, 7 and 8 get more harder. 7 is a convoluted rule, so you actually had to do the division. There is none. 8 means the last 3 digits are divisible by 8. In this case, there's only 3 digits. So we actually have to do that, and when you do that, you get 8 and 36. Okay? 9 means the sum of the digits divisible by 9, so we get 16, 18, and that's true. So when we do 9, we get 32. And then 12, you should know your 12 times table, but or 11, you can divide by this. The rules for 11, I'm going to skip those for the moment. 12, because I want to focus on the actual solution, and 16 and 18 is what we have at the end. So we actually have a long list of things here. And the reason I wrote it out is, let me make this so that we can get all together in the same shot. Is if P times N is 288, that's each of these scenarios here. If we multiply each of these, because they're factor pairs, we'll get 288. So all of them matches to P times N. The thing is, if P in Can that fit on there? If this is P and this is N. It says if the price was 1 less, that's what this is saying, if the price drops by 1, then the marble count goes up by 4. So if we look at all these, there's only a few that differ by 1. Give me 1 second, guys. My phone keeps shutting off because the battery's dead. Let me do something here. Let me okay, there we go. Is that good? Yes, there we go. Okay. So what we want to look for is factor pairs that differ by 1. So 12 and 16 don't. 12 and 9 doesn't. 9 and 8 does. And 6 and 8 doesn't. And 6 and 4 doesn't. And then we're left with 4, 3, 2, 1. So that's the ones where the price would differ by 1. So what we need to do is then look on the matching respective factor pair and see if the price went down 1, did the number of marbles go up 4? It didn't from 4 to 3. Okay? How about from here? If the price goes down 1, does it go up 4? No. Goes down 1? No. Okay? So we're only left with 8 and 9. So if it goes down 1, did it go up 4? Yes. That matched that. All right? So this is one way to solve this problem, is to get your factor pairs and feed them back into the question and the equation and see what makes sense or not. And then once you get the number, run it through again. Run it through the words and see if it makes sense. So it says, so how many marbles did he actually buy? So the answer to this is going to be 32. Don't get these confused. So now if I bring the answers up, this is where kids can lose points. So now you've actually solved it correctly, and you're going to do something like choose 9, which would be B. In the meantime, the answer is 32D. So make sure you know which column is which. In fact, this is true no matter which solution you use to solving this problem. All right? This is basically, so the clue in here was that there were 2 things that when they multiplied, they ended up being 288. And it was kind of clue in, oh, maybe factors are involved here. Now, I'm not going to guarantee you that factor is involved, but if you see something that models the pattern of this question, it's definitely involved. Okay? Now, as I said earlier, this is not the only way to solve this problem. Okay? What you can also use is brute force. So if we look at kind of the numbers, if we take A, it says how many marbles did he actually buy? So if he bought 8 marbles, this is N, right? And we divide that into the 288. Okay, we end up getting 36. We know that already because that was the numbers on the factor pairs. But if we actually did the division, that's what we get. Right? Because we have 240 plus 48, we got 288. So the question is then, how many marbles did he actually buy? If that's it, then it says if a marble had been a penny cheaper, which is 7, would it end up being 4 more? We know that's not the case because that's equal to 280. So that kicks out. That doesn't work. If we go with B, B was 9. If we divide that into 288, we get 32. Okay, so it's the same thing. If we go 8, can we get to 36? Yeah, we do. But remember, there's a problem here. That this is the count and the number of marbles. This is really reflecting answer D. So the 9 here is the marble count, right? And the 32 here is the price. We want it flipped. So this is kind of a fast way, once you realize that if you're solving the problem based on the flippage, because you're actually using the 9 as the count and the 32 as the price. Once you observe that, then you realize, oh, if I flip the two of these, I get the same calculation. Because this is true of A versus E and B versus D. And then 12 is just somewhere else. So if we have 12 into 288, which I think doesn't even divide into it. Let me see here. 12 into here, 1, we get 10, we get 19 actually. So, and then nothing would match that if we go through the same process. So this is really what we're showing is that brute force can be used as well on this kind of problem. But it means understanding what the problem is even about in the first place. And making sure you're keeping track of what's the price per marble versus the number of marbles. Okay? Because again, enough kids could probably end up getting the 9 and the 32 situation versus the 8 and the 36. And they're going to pick one of the other numbers by accident. They're going to flip them. Especially since P can mean price. Right? And whoops, we lost the phone again. All right. There is still other ways to solve this problem. What I might do is just kind of mention them in passing and just leave it as an exercise for you guys to do on your own. And if you want to email me, you can, because it starts getting esoteric from this point already. And it kind of was half esoteric already. So what we want to do is just throw it out there. If nothing else, there's a way to double check. But remember, each one of these creates a lot of time that you don't have on a standardized test. And so if this was a homework or something, go for broke, guys. But on a real test, you probably want to maybe just do the brute force way. And once you have the real numbers, just feed them in, making sure that you have the price versus the count clear. Okay? So let me show you some other ways to do it. The first is to get back to the original thing that P times N is 288. All right? And we also have the P minus 1 times the N plus 4 equals 288 as well. Right? So since these are equal, that means this top and the bottom must be equal. So there's, we can say Pn, the phone wants to shut down, equals P minus 1 times N plus 4. All right? And what we can do is run FOIL on the second one. So we get Pn equals Pn minus plus 4P minus N minus 4. So we get that, right? Everybody see that? And we can get rid of the Pn on both sides. And what I'm going to do is bring the minus N to the other side. So we get N equals 4P minus 4. And if we reverse the distributive property, because that comes up often, we get N equals that, and divide both sides by 4. N over 4 equals P minus 1, and then P equals N over 4 plus 1. All right? So this is a quicker way. So you should be able to go through this in a couple seconds. If you got it right, of course. There's always the room you get it wrong or you get confused. But once you have this P equals N over 4 plus 1, okay? N is the count, P is the price, N is the count. So now we can run through the examples where the answers are the counts, right? They're not the prices. So if we, for instance, take 8, we're going to get 8 over 4 plus 1. So we get 4 plus 1, or P equals 5. All right? So that means if we were to decrease the price by a penny, so if we get 4, will it switch then? So what it means is taking each of the answers now and running through a much simpler scenario than the previous example. And if we run through all the choices, you'll get the same answer again. All right? So there's still another way to do it. Give me 1 second. In fact, there's 2 ways to do it. And I wrote some of the stuff down here so I don't make a mistake on this live stream. And it kind of piggybacks off the way we just did. And it ends up using the quadratic formula, which again is absolute overkill for this problem, but it's just to show that it can be done. So if we have the Pn equals 288, we can also spin off two things from this, which I'm going to say n equals 288 over p, right? That's the same equation. Oh, my phone definitely wants to shut down. If we run through that p minus 1 thing again, the n plus 4 equals 288, okay? And if we spin it all out again, and we're going to get the pn plus 4p minus n minus 4 equals 288, okay? So now what we're going to do is substitute. Anywhere we see n, we're going to replace it with that. So we have p times 288 over p, because that's n plus 4p minus 288 over p minus 4 equals 288, okay? These p's will cancel, right? And we end up with 288 plus 4p minus 288 over p minus 4 equals 288. If we get rid of the 288s, we end up with 4p minus 288 over p minus 4 equals 0. And everybody's like, what the heck is going on here? Well, if we want to get rid of this p here, so we multiply both sides by p, we can get 4p squared minus 288 minus 4p equals 0. And if we put it in normalized order, we're going to get 4p squared minus 4p minus 288 equals 0. This is our A, this is our B, this is our C, and we do the quadratic formula. You know, the minus b plus a minus b squared minus 4ac over 2a. If we plug all those in, we will end up getting the right answer. It's ugly math. It's ugly math. And there's a variance to this, which is that instead of plugging n in here, because what we're going to end up getting is p, whatever answer we get here is p. And they're asking for n, okay? So once you realize you made that mistake, you can flip now and either solve it and feed p into the 288, because you're going to get 288. Whatever the answer ends up being divided by p. What you're going to do is that in this actual example, you're going to get a positive and a negative answer. You're going to throw away the negative one, the positive one's the valid one. And I think it ends up being the 32 in this example. I can't remember the numbers anymore. And if you divide this by the 9 or whatever, you're going to get that right number back out. Okay, if you want to do it straight up directly, what you're going to do is p equals 288. And instead of over here substituting for n, you're going to substitute for the p's, and you're still going to run the quadratic equation, except at the end you're going to have n equals something. All right? So it's beastly. This is beastly. All right? So we have the quadratic formula, we have brute force, we have factoring, and we have kind of doing half algebra till we make things a little simpler, like we did in this one, to end up with this kind of p equals n over 4 plus 1 kind of a thing. All right? All right, so if anybody needs to contact me to actually see the solution for this, I'll definitely email it to you guys or review your solution to it. My email is down at the bottom in there. By the way, I'm Greg from GregsTutoringNYC at gmail.com. I tutor a lot of different subjects, homework help. Really like to focus on math, a lot of English as well. I also like to focus on specialized tests. They're super fun. I like working with smart kids, and it's interesting to see that light bulb go off in a kid's head. And it's also fun to crawl on a kid's head and be teaching them these kind of insights and techniques and observations and things like that. So again, there's about 8 weeks left until the SHSAT. The Hunter test is coming up as well. In fact, I believe this problem was originally derived from a Hunter high school test question that I had run across. So this applies to a lot of different tests. And it's a nice doozy of a problem. And if you go through all the different solutions, you have that in your toolkit again, guys. All right? Okay. I'm going to peace out, and hopefully this stream lived because my phone wants to die. All right, people, have a great day.